Let's play that video. Hello. So this was brief introduction of Sikya Anusandhan deemed university. So today's lecture is about the role of machine learning in computer networks. And the speaker of today's lecture is Dr. Pravati Swain, Assistant Professor, NIT Goa. So before going to the lecture, I introduce you about Dr. Swain. So, Dr. Pravati Swain is an assistant professor in the Department of Computer Science and Engineering at National Institute of Technology, Goa, India. Prior to NIT Goa, she was research associate in the Department of Computer Science and Electrical Engineering at University of Missouri, Kansas City, USA. She has a PhD degree from Department of Computer Science and Engineering, IIT. Is it audible? So Dr. Swain also interested in applying data-driven approach.
Not audible.
Not audible. Sir, it is actually automatically going mute mode.
Okay.
Okay, Dr. Swain has guided 10 master students and 3 PhD students are ongoing. She has published over 25 research articles in reputed journals and conferences such as Transaction on Mobile Computing, IEEE, Computer Network, elsewhere, SOA conference in ACM. Dr. Swain is associated with many conferences, organization committee such as ARNS 21 IEEE, CCEM IEEE, ComNet SAT IEEE, and many more. Okay, so now I request Dr. Swain to deliver her lecture.
Thank you. Thank you for having me here. Good afternoon, everyone. Instead of wasting much time, let me share the screen. Straightforward, we will start. Yeah. Is my screen visible to all?
Yeah, madam, it is visible.
Okay. 1 second. Yeah, as I came to know that this is a regular lecture for the SOA University for the students and the faculty. My research domain on computer network, but one of my PhD student recently started working on the machine learning applications on computer network. Not exactly computer network, if I'll say it's a huge, you know that, right? So the specific network is called the software defined network. There we are using the deep learning models. Well, this is a basic discussion we will do today. Why machine learning? The different workflow of the machine learning in networking, means the computer network, the neural network, convolutional neural network, or routing using CNN in SDDCN. I will come to the last point more detail, which is our research work. Am I audible?
Yes, madam, you're clearly audible.
Yeah. Screen visible, I guess.
Yes.
Yeah.
This
So
visual.
let's start from here. What is machine learning? This term, if I will take in the traditional definition, what is machine learning? I think almost everyone know what is machine learning. The ability to learn without being explicitly programmed. What it means that, when we give some programming like in C or C++, we give that the task to the student that this is the input, this has to be the output. That means we know the input, we know the output what's supposed to be, and the task is you need to design the whole algorithm and write in a particular using some language, programming language. So that's a point. But now little going one step ahead, that we have to train the machine, or we have to give certain idea how to learn it from what, I don't know, that is a different point, like data, but training data, testing data, that is the different technical terms. But in general, to explain some non-CS person that what is that learning, so we will give the idea or the method how the system will learn, so that we are not programming the whole task, we are not programming explicitly what's supposed to be the output, but the machine supposed to learn in such a way that it can explicitly understand what's supposed to be the output. The prediction, one example is the prediction. So the goal of machine learning is to identify and exploit hidden patterns. That is the important features of the machine learning. That's the reason, I guess, in my belief, that the huge impact of the machine learning in the today computation, which identify the hidden patterns and exploit means it explore more patterns, right, in a from the training data. So if your model is a good model, it can exploit the all possible hidden patterns, then it is very much appreciable. The patterns learned are used to analyze unknown data, such as it can be grouped together or mapped, or so this is the more detailed point we are going. So why machine learning? Why machine learning suddenly booming and everybody is interested now in machine learning? At any n number of domain, you can see any non-computation domain also people are using machine learning. Why it is suddenly happened that whole industry, everyone interested in machine learning? One basic factor I believe in the domain of the computer network, the explosion in the availability of the data. Everything now running behind the data. Like I will give all the examples related to the computer network point of view. We know the term is the 5G, IoTs. IoT is very well known these days. So when I come to the point called IoT and 5G, there is lots of data in the market now. And from the data, how can we build a good network? When I say good network, means the performance of the network has to be increased. So performance in the different point, I will come more detail of that. Significant improvements in machine learning techniques. As I said, one point is that the huge explosion in the data, that is the requirement of machine learning. Another point also, the different techniques which are very very nicely defined or designed or these days developed, different ML techniques. So you very famous, that all the deep learning techniques, right, these days, right? So the next point is advancement in computing capabilities. To compute the ML models, these days, if I'll say the deep learning models, we know that we need a very high computation, machines and all. And this is not a big problem, big deal these days. If you have experience like, 10 years back, to your laptop is not able to handle that high power, MATLAB programming, anything. But these days in a single laptop, you can run even a, high much data, you can run it. So it's not a big deal. Through the cloud that I have written here, the cloud is one beautiful thing given by the scientists, that cloud computing. And there is lots of advanced things are coming in the edge computing, fog computing, blah blah. So these are helping, even if you don't have a big nice system and high computation server, blah blah, but still with single laptop You can run that through the help of cloud. Let us assume that Amazon cloud, right? You can just get the for 1 month rent from the infrastructure as the service from the cloud, and you can run it. So that's not a big deal. So that's all, these are the important features I believe. That is the we need ML in every domain, and basically in computer network. So what is the different categories in ML? Some problems you can see is the clustering problems. Like the data is given, you divide into different cluster based on their rules. Like these are the data points having similarities. So this is in one group, and this is having the different similarities. So depend upon the features, what features you are picking up, and based on what theory or the function you are defining into clusters. So one is the clustering point of view. Some data we need classified. So this is the classification rule that we are dividing. So it is depend upon the model, as again I'm saying, the depend upon the model. So sometimes I need the data is this is the right classification part. One third one is that the regression models, and the fourth one is the rule extraction model. So these are the basic, abstract division of all the problems in the machine learning to exploit the hidden patterns and to identify. So this is the rule extraction. That means you are going to define a rule as such. When the input will give, this is the transitions, and the what would be the future transition for a given input, right? So that's the rule extraction. Well, in short, the whole machine learning divide into different type of problems. One either clustering or classification or regression or the rule extraction. So you as the engineer need to define your problem is coming under which category, what type of model you are going to work. Well, so what is the network challenges? All these are the discussion about machine learning. Now come to the point of networking. What is the problem we are facing in networking, so that we can go for the machine learning as a solution. The first problem, we believe that network is not unique. Each network is, I mean to say that each network, the design of each network is different. Like the number of devices, the way they connected, the data rate of each link, the data speed in the output link, all these are different from one network to another network. So we cannot train a model by taking the example from another network and I can test it in my own network. So that's not possible. So that is one point. Second point is the network is continuously evolving, and the dynamic inhabits the application of a fixed set of patterns. That means, let's take on the example of the IoT devices. So the whole network is the design or the connectivity of the network dynamically changed. The traffic, which are the 20 years back, the data traffic was almost like a standard and predictable. What's supposed to be the data traffic from today or after 1 hour or weekdays or weekend. But these days, as the growing of the 5G concept or the IoT, it is really difficult or next to impossible to predict. But still, our job to predict the traffic. Why we need to predict the traffic? Once we predict the traffic, we can expect the good performance. We know that if we know somehow, we can predict that what's supposed to be the traffic right now. So somehow we can properly utilize our resources. When I say resources, means our bandwidth, important is the resources, is the bandwidth allocation is one important point, the spectrum point of view. So we have a huge amount of data, and it comes very fast and in diverse. That is the one factor or the challenge in computer network. Well, come to the point of workflow of ML in networking. Let assume, as I said, I skipped this important point. These are the applications in where we use the ML or the machine learning techniques to do the traffic prediction, which I explained a little bit. The traffic classifications, performance predictions. Yeah, let me tell here. The performance prediction means the performance, we know the networking, the basic performance features are called the throughput, delay, or the jitter, or the utilization, channel utilizations. So all these features we generally calculate, like when we will say that this model is a good model, we, if even if this network is giving a good performance, what it mean exactly means, it is the, if there is a x amount of resources is allocated, maximum possible utilization has been done. That is that the spectrum is a very important factor. We don't want to waste that, if it is a licensed network. So the fault management, that also very important feature is the fault management. Network security, this ML techniques are highly used in network security. Well, the workflow of ML in networking, but this is, I believe it's the standard flow in almost every domain, but still specifically for network point of view. Am I audible?
Yes, madam. Yes.
Yeah, any point, please stop me, because I'm not going to very first. I don't want, because I need to, basic has to be clear, I believe. So other thing is just the person to person based on their research, but basic how the ML is using in networking, that is my idea. Well, as I said, the whole problem we can define it is in which type of problem, either prediction or regression or clustering or decision making, that we need to define your problem formulation. So problem formulation is the first challenge of a researcher, to define the whole network architecture and how they are connected. That is called the system model. After that, the idea has to be clear what you are going to do, right? Sometimes I believe it sounds very bad, but it's really true that the student has no idea what they are actually expecting, for what reason they are doing this modeling, but they are saying I am doing some modeling using ML. But what is actually is going, is it a prediction model or is it a regression model? What type of model it is? Okay, so that has to be very clear in the beginning. The second part is the data collection. Data collection is is a very important factor in networking. As I said, each network is unique itself, so we can't generally, we have to take the pain and to collect the data for the particular network for which you are going to design the model. Let us assume the prediction model. For the data collection, the ML techniques require representative data, as we know that and if I will go one step ahead, the deep learning that needs the huge amount of data. If you need the perfection in the prediction, if it is a prediction model and you need as close as it has to be predict, so you need sufficient amount of data. Okay, so that's the important point. And this data can be collected with the offline mode or the online data collection. Offline data collection means it's already it's you just put a, I will tell more detail how it can be collect. So let us assume you have a certain black box which collect all the data of your whole university, and next day you are coming and your model, you are giving the input all this data to your model and doing something XYZ, all the work. Okay, so that's the offline data. But online data is like you are training your whole model, or your model is going to be better or the better stage parallelly. Like some data is coming to your model doing some XYZ, that black box I say in the beginning. Then again it's coming another data. So it's like a feedback method, right? So every time your feedback is coming, and based on that your model is getting update. So it's just the online data collection, and our research we do it on the online data collection model. The data collection in networking, an effective way to collect both online and offline data is by using some monitoring and measurement tools. These tools provide greater control in the various aspects of the data collection. So as I said, there are different tools for collecting the data. You can monitor or measure the whole network data. We have used this ITER. It is a measurement tools for the data collection for our work. The data collection that can be decomposed in the two different way. Either one way is called the training, validation, and tested data. So the three division, one is the 60% of your whole data is the training data, 20% validation, and 20% testing data. I think you people know, but if not, I will explain more detail. Sometimes people divide the whole data is like 70% and 30% is the 70% for the training and testing when there is a validation is not required. So this is not, again I'm saying, this is not the standard way, sorry, this is not the static or the only way to divide 70 or 30% based on the observation. Sometimes people do the different division of the tenfold, 9, 20, I don't know much detail, but I know only the tenfold they called it, right? So every 10 division they do for the testing. Well, so that point is also one experiment point of view. You can divide your data at percentage, how much you're supposed to take for the training or testing. If there is validation, how much for validation. Next step, what we did, we have divided our problem, formulated our problem, what type of problem it is. Second, we did the data collection. Third is really one important part is called the data analysis. Data analysis, as I said, machine learning, one important feature is that to extract the hidden features, right? So hidden features or extract the hidden patterns. So feature extraction through that feature extraction is one very important factor in your modeling, in your data modeling. Which features you supposed to pick up, which features you supposed to ignore. Well, and some features may not be very clearly shown in the data model. You have to recreate some features from the given data. Okay, so that is the one, I believe it's the most engineering work has to be done here in the feature extraction point of view. That's the beauty of the deep learning, that we are not going to specifically define this part, but here there in the previous time in the artificial AI part, we were doing lots of work here. Let's go to the point more detail. The feature selection or the feature extraction, as I said, which features are important or the relevant and which are the very redundant that not required, that is the one called the feature selection. Similarly, feature extraction is the derived or extend the new features from the existing features. Fourth step is the model construction. Model construction, now we have the data, we have selected this 1, 2, 3 features we are going to pick up. Now we are going to do the training of your model or the testing, training and testing we are going to do here. And for that we have several methods, and this is very well known picture and everybody know all these techniques, I believe. The supervised, unsupervised, semi-supervised, reinforcement learning. And we know the supervised means the data are labeled data, which is not always available. So some data is unsupervised data, like the social media data, they are not much labeled data. And reinforcement learning, that is a beautiful technique, I believe. In the networking, mostly we people use the reinforcement learning because it's a reward system is there. So every time the whole system learn through reward functions. So, and again it gives some output. It's like the environment is one important factor for the whole decision process in the reinforcement learning. That's the reason in networking we believe it's a good model. So then the cross validation, like whether it is the achieving your requirement or not. If not, then again you go continue and do all the process. After this data collection, we are doing all these process, and if it is yes, then go for the deployment, trade off on speed, on memory, and stability. So all the system point of view, accuracy and the interference, or the if I'll say is the proper utilization of the spectrum or not. Yeah, these are the different performance matrices, but it's not system point of view, it is the model point of view. In machine learning, we people use these are the machine performance matrices is called the mean absolute error, mean squared error. So only one parameter, let me pick up any one and explain what it is. Actually it's prediction, right? We don't know exactly what's supposed to be the output, but we are predicting that it's supposed to be. But let's assume that that you are training your whole model, right? So when you are training that, that output has to be this. Let's assume this is let me write it here. Yeah, Least square approximation, that example, if I will give, that is best, I believe. So these are the data points are given, and it is told you to draw a line which is uh, best fit of these data points. And the line, we know that it's not possible to cover all the, straight line is not possible to cover all the data points. So our target is to draw a line in such a way that let assume this is the line I draw from the zero. Okay, so this is a line I have drawn, and my target, that the distance, which is the exact, actually the best solution is this here. Here the error is 0. If the line could pass through this point, here error is 0. But as the line is not exactly passing through data point, so it is little far, and how much error is this much. Similarly from here, how much error is this much. So that is the least square approximation, right? The minimum error from the line, which is our prediction line, and but this is the exact. So what is the minimum square error from this? So that is what is that, the mean squared error or mean absolute. So these are the different error methods that we calculate, that how perfect your model. Sometimes that is also not sufficient to calculate if your whole data set is not in the it's in the confusion matrix we need sometimes, because your data is not fully balanced. So that case is like false negative, or the true negative, true positive, false negative. All these are the different parameters we calculate to analyze your model. Yeah, now we are moving towards to more detail about the deep learning point. So before that, let's discuss what is neural network and what is the difference in deep learning. Neural network, it's a very old technique. Uh, we know the input, these are the neurons. Very simple point, everybody knows that these are the neurons, and it is the image or the idea came from the human beings only, how the human brain trained, or by looking into a picture or something, how can it identify that what it is it an animal, is it a tiger, or it's a lion, what is that? So that is the idea that came into the neural network point of view. These are the neurons, and so something is hidden, not very detailed, it's just abstract model. Some activation functions are there, some biased, some weight values, based on that we calculate, and this is input and this is our expected output. These are the hidden. Here in this picture only one hidden layer is given, but it could be multi-layer neural network. Okay, so multiple layers could be possible. Well, so now what is the difference in CNN? What is CNN? The convolutional neural network. Is it very fast? Everything okay so far? Any question? Or the questions are to be at
Questions,
the end?
yeah, we'll discuss the
Okay,
questions at the end.
okay, fine. So yeah, let me discuss about what is the convolutional neural network. As I said, just let us assume the neural network one part. So what is that extra point in CNN? How it is different from the neural network? The convolutional layer, but this is the people standard architecture people so as a present. This is the convolutional neural network. But what it is exactly, we know that is the input layer is there. What is the meaning of these slices, right? This is one matrix. Let us assume this is one matrix, this is one matrix. What all this? Well, your data, let us assume it is in a tensor, means the uneven size of the matrix, like m cross n size of the matrix, and m cross. Okay, let me write it here. So m cross n size, the matrix size is this, and let us assume the k number of matrices are there, and not necessarily it's the diagonal matrices. It could be the any size of matrix. The convolution layer, what it does, the convolutional layer, and there is another layer called max pooling layer. All these I will explain a little bit more detail. Let's go through the just acquainted this term: input layer, convolutional layer, max pooling layer, flatten layer, and the output layer. And here it's the dense, like multiple, as I showed, the multi-layer perception neural network, that is this. Well, more detail I'm going to explain here. This is the input of an image. By the way, everybody has a must have a curiosity. Like, we know the CNN used in image processing very well, but how come the CNN can be used in networking? I faced this type of question several times. It's a very well known question. Also, I will come to that. Yeah. So this is the image of a deer. That feature. First of all, we are going to let assume that we are going to predict its what is the percentage that this is a deer. So the percent, and this is the different animals: dog, cat, deer, lion. Well, we assume several things, that we have a well-known filter which is identify this eyes is the eyes of the deer or a lion, like this. Later we have a filter which can identify the ear. It is for which animal the ear, right? So let's go one by one. We are going to our target. I said we are going to see the face. Okay, so in this face there is different features are there. One is the eyes, the second one is lead horn, third one is the ear. So we are not taking care of the whole face of the deer. Okay, so here let us assume this is a of the whole deer face, but we are not going to give this as the whole input. Well, so what we are going to do, we will it will as a input, but when we will do all the process here, we are not going to work on the size of 1024 or 12. We are going to compress it. Compress means we are just looking into the local minima, means only the part of the eyes, that's called the local minima. Means our target is just to identify these eyes. And next phase means here, let this the first phase is just going to target on the eyes. The second one is going to target on ear. Third one is going to target on the horn. Fourth one is going to target on mouth, like this. So that's the each phase we are looking into the local minima. At the same time, like I know somewhere I heard it, I read it, like when a human being sees some picture, it's not looking into the overall and identify now this is XYZ, this is animal, this type of animal. What they do, okay, so this animals, this eye is supposed to be round, to be some rat, or this eye is supposed to be little oval size. Like this is the way we recognize something. So that means that's called the local minima. One specific features we target. And the benefit is we are not computing everything at a time. We are computing with a minimum data. So that's the basic difference of the CNN with the neural network. As I said, well, so this eyes, some filters we are putting, and some particular space that 1 and 0 values, or not 1 and 0, some numerical values, real numbers, it's there in the filter, and somehow let it detect that this is the eye of the ear. Similarly, the ear and the mouth, the horn. So all these are coming. Well, that's the convolution layer, the feature maps, right? In term, it's called the feature maps. Then something is here which is not written, that is called the activation function, the ReLU activation function, the very standard one, ReLU activation function. What it does, it just take the negative values, it can make it 0, and the positive as it is. And that function is, if it is the negative direction, it will be 0, it will be 0. And whenever from 0, it will be positive, like this, linear, I guess. Yeah, like this, straight, no turning, it's straight. So simple point, it's just negative, it's removing all the negative values, that making 0, and all the positive as it is. So that's the activation function used here. And next is a pulling step. What we are doing, the pulling the different two, which I know. One is the max pulling or the average pulling. Max pulling, I will come more detail about it. which is reduce the data size in the pooling stage. And repeatedly you can do the steps, you can repeatedly do the convolution, again pooling, convolution, again pooling, blah blah. So till these steps it is called the training, right? You are doing all these, the training or the feature extraction point of view. Now the second part is the prediction part. Prediction start from here, the fully connected. What is the flattened state, right? In this picture it is the flattened state. Whatever the data after max pooling, we are making it the flattened, means we are just a one dimensional array. Okay, so that dimension, all the data instead of the multi-dimension, now it is the one dimensional data input to the neural network. And why we need the neural network? Because we are going to the prediction. And what we did in the convolutional layer, we just somehow went to the idea of the local minima. Instead of taking the whole data size and making your whole system overloaded, we are trying to compress and only looking into the important features which is we need for that timing. So that is the idea of the convolutional layer. And next part is the similar as it's the multi-layer perception neural network as it is. This is one of the example of the image. Like this is the image where the buildings are there. Wherever there is the buildings, that is 0. Where there is no buildings, that is wherever there is building, that is 1. When there is no building, that's the zeros, you can see. And these yellow parts means the whole input data. You are only pick this much size you are looking. So this is your filter size. Let assume this here the filter size is 3 cross 3. This yellow part is the filter. So from this part only your filter is going to check it. Okay, so this is 0 0 0. Okay, so then we are going to identify, let's say, famous city, and this is the filter size filter which is going to say that yes, it is the picture of that city or not. So if it is matched with this filter, and by the way, this is the slider is also there. So like this 3 cross 3, next time I will move for, let assume it is the slider is 2. So from here it would be another 3 cross 3 matrix. So that's the value. So this is just a simple example, not a concrete example. Yeah, I was telling about the pooling. What is the pooling? Is this is the example of the max pooling. Max pooling means, let assume that your features that you are taking, that the filter size is the 2 cross 2 matrix. So what you are going to do, this is a 2 cross 2 matrix. Instead of taking the all data of that 2 cross 2 matrix, you are taking the maximum of that. So here in this simple way, it is just 6. Here it is 8. Here it is 4, and here it is 3. So now the whole features is going to be compressed to a 4 cross 4 matrix. It is a 2 cross 2 matrix. Previously, it was a 4 cross 4 matrix. So image, we know that several techniques are there. Instead of sending the whole image, we need the important features of that image which can be recreated at the lower end, right? So, but it is not the point. But here we are doing the processing, right? Whole data we are processing. But it's saying that instead of process the whole data, we can process this much to get the output. That's the idea. Well, among all these, now all these examples was point with respect to the image. Now, by study all these, we have used this idea in the networking. Do I have time? I guess, yes, we have. I have 10-15 minutes more I have.
Yes, yes.
Yeah.
We can continue up to 5:20, 5:25. Okay.
Okay, right. So intelligent routing using CNN in software-defined data center network. So we have taken the environment is the data center where the software-defined idea is there. Software-defined, if I will, by the way, this work we have published in 2022 in a journal called the Supercomputing. If anyone interested of this type of work, you can get more detail from this paper. It's already available. So what is the software defined network? In the traditional network, we know the OSI model having 7 layers of the OSI model. But here it is not very standard way of the OSI 7 layer or the TCP/IP suite of the 5 layer. It's different in this way. It's called the 3 layer with the data plane, control plane, and the management plane. So the data plane is nothing but the all the infrastructure are connected devices, the switches. I'm talking about the layer 2 point of view from the OSI model. The all these devices having the layer 1, layer 2. Okay. Uh, the data link layer till that, so that's called the data plane in software defined. And the control plane means then all the routing decisions is going to be not taken at the data plane or not at the router, the switches point of view. It is somewhere programmed and decision is going to taken somewhere else. That's why it is that's the beauty of the software defined network, that whole decision of the whole network management is going to be programmed or it is programmable and taken somewhere else. So the network administrator, let assume sitting in USA or somewhere in the different continental, and he's managing your university network, right? When I say university network means, let's say assume that you have a big institute having the lots of traffic, and that has to be routing has to be well managed, but that network administrator not supposed to be sit in your university campus and do the you know the decision has to be taken. So it could be do anywhere. So that anywhere point, that's the beauty of the software defined. The name itself, software defined network. So the network is now software level programmable. Well, so the another point layer is called the management layer, where all is there. Well, we work on these two layer, control plane and the data plane point of view. Yeah, in OSI model there was different interfaces. Similarly, here also interfaces are there, northbound interface and the southbound interface. If you really interested to learn more about the software defined network, it is lots of literature is there. One second. I like to write one important point. It is called the open flow. This is one software which n number of other interfaces, but this is very well known, open flow. Any question here? Oh yeah, as she said that Madam said it's the questions at the end. Okay. So the now our work, this whole architecture is proposed by us, our group. So the CNN deep learning model in STL. As I said, this is the data plane. All the I have mentioned one term is called the data center, right? So data center, we know the Google have own data center, Yahoo have their own data center, Amazon have their own data center. What it means, like that similarly they are sharing their infrastructure, right? They are sharing their infrastructure with others through the cloud. We must have the term called the cloud. If I heard this question several times, what's the difference in cloud and the software defined network? So the cloud is one service, I mean, or I can say it is one interface through which you are giving the service. So there it is called the cloud as a service, right? When you are giving your infrastructure or the whole this computation devices as a service, that is called infrastructure as a service. Sometimes when you are giving some applications to the other as a rent, so that's called the application as a service. Well, that is one point. And the software defined network means it is not going to this is like a management, how you are managing the whole network, whether it is a software based management or it is a tradition, how your whole network is managed. Okay, so I guess you can understand the difference between cloud and software defined network. Software defined network means how your network has been designed and how it is managed. Either it could be traditionally designed and managed or it is software managed. So if it is software managed, then it is called the software defined network. So the whole data center, there is a cloud environment which is giving the service to the users. But if your whole data center is softwarely managed, like all the routing data is coming to the data center or going through the data from the data center, and all these routing and the flow table managed software basis, so that is called the software defined data center. I believe you a little bit clear to everyone. And there is a different architecture how your data center supposed to be connected. It's the networking point of view, like the design point of view, and this architecture is called the factory. This is called the factory. There are different data center architecture is there. I don't remember much, but I guess D2, L2 is one there. Is called L2, and yeah, I don't remember much. And this factory is very famous because of this tree structure, and it is well managed, and it can be identified the flaw, the some flaw, any fault in the channel destruction, and it is if it is something, some line is broken here, and it is easily recoverable. So that is a lots of research that, and conclusion is the factory is the, from user point of view, factory is the better one. Well, so we have considered the factory topology. Factory topology also different sizes there. Why it is, you can see it looks like a tree, right? It looks like a tree structure, so that's the tree. And why it is factory, and there is another called term is called the fully connected tree, so that is little different from that. And so instead of going to that point more detail, let's go to my work point of view. So this is the data plane, how the tree structure, these are the servers in the data center, these are the switches, and these are we call the edge switches because it is close to the server, and these are the aggregation switches because this connect to the switch to switch, so this is the aggregation switches, and these are the core switches, and this is my whole network, the data plane. Okay, so idea is someone is requesting some data from this server, or the routing from this server to this server. So don't forget about the pod 1, pod 2, what it is. Well, so the idea is we are going to update the table or the routing with minimum delay or maximum throughput. That is the target. What we are doing, we are having one routing algorithm. This algorithm we and we have modified certain these algorithms. After that algorithm, we are trying to make it is taking the decision in the on time decision, like the traffic on time, real time traffic. Based on that, it can take the better decision. So how it can make a better decision in the real time? Through the deep learning. So this is the deep learning agent, and this deep learning agent we have deployed at the view controller, the control plane, and we are giving the decisions to the routing as the parameter, input parameter. Based on that, the routing agent taking the decisions, which is in the management plane. Okay, and that is sending the decisions to the controller, and the controller are sending that decisions to the flow table, which is there in the data plane. So this is our proposed idea, and how it works we have implemented more detail. As I just discussed the flow diagram of the ML, similarly we can make a comparison here, that in ML we need the data collection. Well, so this is the data collection phase, and there we just monitor the whole data using some tools. So we have used ITER tool. Then the raw data has been pre-processed, means we extract the data which we don't need. We have look into the which features we really need there, and after that we are sending that the input. Here the TM is the traffic matrix. The traffic matrix having two features. One is called the available link bandwidth, and the received data, and the sorry link weights is one dimensional array. This is each link having the weight value, and that is a function I will tell you. By the way, here we can see one important thing we have to see. Each switch, this switch having 4 connections. This is the, this here the to the connected to the server, these 2 are connected to the switch. So the each switch having the 4 port. And how many switches? 1 2 3 4 5 6 7 8, and here 8, here is also 8. 8 8 16, 4 20. So 20 number of switches, core switch, aggregate switch, and S switches. So the 20 is the number of switches, each switch having the 4 port. Well, we'll see. Why I'm saying, because it is required in the modeling. So this is the data and going, and here the CNN is train the data. As I said, it's online training. We are doing the update, we are updating that information to the routing algorithm, and the routing algorithm doing the decision, and it is repeatedly going on. I repeat, this whole process, the deep learning process, it is a continuous feedback process. The data input to the CNN. So the data input to the CNN is, as I said, the TM, the matrix. It's a tensor. It's the tensor of the size this. Let me go. Yeah, this is the better picture. So this is the tensor input layer. Input we are giving of the size of the matrix is the 20 cross 4 cross 2. I guess the idea you can understand. The 20 is the number of switches. 4 is the number of port in each switch. 2 is the features. Well, so the 48 is the number of links. So that is the input, and we are doing the convolution, means each features we are putting the filter, and this is the beauty of the CNN. We don't need to define the filter. It is to periodically the filter updated based on the data. Then the filter extracted and the size is reduced to this much. Then we do the max pooling, and after that we do the flatten. And we have considered two convolutional layer, one max pooling, and then we do the flatten and do the update to the neural network. And these are the results, and we have observed that in the result section. Yeah, with this result we have we did it in the mini network environment, and we collected through the ITER all the data. And we have observed our proposed CNN. If this is our previous work, flow decision, the green color, without intelligence, you can see it is this much the delay. But when we go for the intelligent network, and the delay is very less. But at the time of the simulation time, 20 seconds, even if it is the with the CNN, without CNN, or only neural network, does not matter. Why that such things is happening, and slowly the difference we can see. Slowly, and here is the huge difference, and slowly the difference we can visible. Why it's so? Because that initially at the 20 second there was not much data. As I said, we need a good amount of data to train your model properly, that deep learning model. At the 20 second, the network is not saturated. It is very unsaturated situation, so it's not properly trained. Similarly, in the average network throughput, we have also analyzed the packet loss rate and the bandwidth utilization. Yeah, another thing also, that is the recording interval. So the data, the way you are recording the data, that also we need to observe whether it is the right way. We have record the data at the rate of TU, what's 1 second, then the 2 of the TU, 3 times of the TU, 4 times of the different recording interval. Also we collect the data and we train the model and see the result. And it is observed there is an impact, but not much impact, not much difference, but still there is a difference, I believe. For all the parameters also we have discussed. Yeah, and that's the beautiful question generally when the reviewers ask that well, all these things we are getting good performance, blah 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 blah. What about the training, all these collecting the data, doing? So that must be some cost. To getting some benefit, there must be some cost. So that's the trade-off we have analyzed. Yes, there is a cost or the delay to do all these computation, but that delay is not much. Even your traffic load is going very high from 20 MB to 135 MB, In the standard flow decision routing, it is taking 120 seconds, whereas in ANN it is taking 120.9. It's like 1 second, approximately 1 second more. Here it is approximately 1.1 seconds. So that 1 second we can give that cost with respect to getting a good performance and the prediction. In conclusion, we have proposed a deep learning model in software-defined fat tree topology for online routing strategy. As I said, online means it's a feedback method. Continuously it is getting the data and update your model. This strategy learns from the previous network traffic patterns and select the best path that improves the network performance, the routing. So the experimental evaluation shows that the proposed work can avoid the congested path, which improves the average network throughput, average delay utilization, bandwidth utilization, and reduce the average network delay and packet loss. So that's the from my side. Thank you very much for your patience. Thanks for listening me. Any question, I am here to reply.
Any questions from the audience?
Good evening, ma'am.
Very good evening.
Whenever we are saying that machine learning is going to be applied on the networking areas, so nowadays drone network is very much popular, which is
Sorry,
basically
drone network, right? You are
Yeah.
saying, yeah,
Yeah,
very good.
yeah.
Yeah.
So one of the constraint for the drone network is the energy. And whenever we will go for such a deep learning approach for that drone network, so whether this will be a overhead for that network?
I really very appreciate for this question. It's a very valid question. And my present work we are doing on the UAV, the drone, as you said, the UAV network, unarmed vehicle networks. The deep learning is really it is an impact. It will take the energy, because we discussed that all the task has to be done at the drone, and drone based on the size of the drones, right? So if it is a micro drone, this is a small size drone, definitely not advisable to put all these modeling things there, do all the computation, because they need high computation. Of course, they need energy. So we don't go for the micro computers, micro UAVs. Instead of drone, I will speak the word called UAV. So that there it is not advisable. But in the next level, if we go to the surrogate drones like medium sized drones, right? They have the little high computation and the battery level is better than the small size drones. There we can use, or we are using when we are talking about the edge computing point of view, because they are close to the edge server and they do this modeling. And I like to highlight one very good point, that I did not use the deep learning there in EAV network. We are working on the federate learning. Have you heard it before? That
Yes.
the real, yeah, the federate learning. Yeah, so the federate learning is highly used in the edge computing, because we are similarly like here, we are not giving everything we don't compute at the same point, right? So federate learning feature is the very specific point. You just pass the very important features to the next model, they will do all these computation. So in conclusion, instead of the micro drones, we are looking into the surrogate drones, or the macro level, the medium sized drones. They do the federate learning at that point and send the data to the edge server. So edge server do the combination of all the inputs and do all the calculations. So I believe it is
Yes, ma'am.
you
Yes,
got
ma'am.
some idea. Yeah.
Yes, ma'am. Yes, ma'am. Thank you, ma'am.
Yeah, thank you. Any more question?
Ma'am, at the control layer, we were having a routing agent, right? So my question is, one routing agent is capable of handling, I mean, how large network? Or basically, I want to know that how many routing agents are required at a control layer so that it can manage a large network.
Yeah, I understand. So the whole thing I explained through only one control agent, right? One controller. When I said let me go to that slide. Oh, 1 second. Yeah, this is the best good slide. Is it visible?
Yes, ma'am.
Yeah, so here I explained the control plane. I did not say how many controller, but in our work we have considered only one controller. But virtually it will look like a one controller. In practical, it is not only one controller. Depend upon the network size, you people do multiple controller. But for the user point of view, like the data plane will understand there is only one controller. Okay, but in practical there is not only one controller.
So one controller can handle, I mean, how many nodes in the network or switches?
Oh, that is not a straightforward answer. Is not that you are saying now that how many controllers, like if I have a network of the n size devices, how many controllers I supposed to deploy, right? That's the question.
No. Under one controller, how many nodes, network nodes can be?
Yeah, the same question you are asking, like the under one controller, how many devices can be properly manageable?
Yes.
Yeah, so that I don't have a straightforward answer that exactly this much you can, based on your whole network traffic or the management. I don't have the exact answer for that. But I'm saying that whenever a people explain about the software defined network, they explain like a single controller, but there is a point of the multiple controller or the controller placement. There is also another area of the work people do this, computational geometry people, they work on that, how many controller and the placement of the different controllers. So I really don't have the exact straightforward answer. Under one controller, how many devices can be handled? Like in cellular network, one base station can handle 250 devices. That is the theory is saying. Or on practical, what is true? Hardly 12, right? Hardly 10 even, right?
Okay.
Yeah.
Yes, ma'am. Thank you.
Thank you for the question.
Okay. Any more question? Okay, no more question. So on behalf of the Department of Computer Science and Engineering, Institute of Technical Education Research, Sikya Anusandhan Deemed University, I extend our heartiest thanks to Dr. Pravati Swain for delivering such an interesting talk from our busy schedule. And the topic was so interesting also. And I would like to also thank our head of the department, Professor Dr. Pravati Misra, for supporting and conceptualizing the webinar series. And last but not the least, I thank you all the audience for the patience and for this to make this webinar a successful one. Thank you all, and thank you, Dr. Pravati. Thank you for your valuable time.
Thank you, Devbhavati madam. Thank you, Sipra.
Okay, so we can wind up here. Okay, we can wind up here. Thank you.
Thank you.
Good. So we can